What's up, math scholars? Mrs. Harp here. We're doing 7-5 day 2. There's a lot of action people, so I hope this video gets 1 million views and a lot of likes and comments. So make sure you hit subscribe if you haven't yet, because I'm in a race with Mrs. MacDonald of who can get the most subscribers, and she's winning. Not cool. Okay? I have way better YouTube channel. Alright. Who's excited? You know why they're excited, because I'm not going to be here tomorrow, so it's basically Friday right now, and this is the last section in the chapter. So, what we're doing today is looking at looking at sequences and coming up with an equation written recursively to summarize. We actually already did this problem when I remembered I didn't start the video, so let me just recap what we did. Our first term was 3, you can see that right off the bat, right out front. And we figured out they were adding 10 each time. So that means my constant difference, my d value, was 10. And here's how we wrote it recursively. We did a big curve to kind of combine our thoughts together. We initialized the sequence by saying a1 equals 3. And then we said from there, to get every other term, you'll refer back to the previous answer. That's what the a subscript n minus 1 means. And you will add 10 to that. So there you have it. That's your answer, what you're seeing in the black box. Cool. Hit pause if you need to catch up if we're moving too fast when you're watching the video. All right, what are we seeing happening here? What's our first term? That's an easy thing to come up with. Now, there's either a constant difference and they're adding the same amount each time, or there's a common ratio and they're multiplying the same amount each time. You can kind of tell by how quickly the numbers are growing. The numbers are growing very fast, right? There's probably a common ratio. 2.5, yeah, so they probably got that by doing 40 divided by 16. But you just want to verify that works for all the other numbers. So is 40 times 2.5 100? Yes. Is 100 times 2.5 250? Yes. Okay. Let's write out our recursive equation. How do I start? Perfect. You initialize your sequence. And then from there, what will we do to each previous answer? And that would be your equation. So what you see in pink is the final answer. Easy peasy so far? All right. I'm going to call up a student teacher for the next one, and it'll be up to them if they want to be recorded on the video. Okay?
All right, class. It's Mr. Burns Ward here. And we're going to do question number 5 here. So we're going to start off with our A1. We know that's 2. It's really not aligned. And then what we're going to do is we're going to divide the second term here by the first term. Wow, that is really bad. And we get 7. So now we know so we write down A1 equals 2. We write A of n equals A n minus 1 times 7. That is how you do number 1. Any questions, class, or viewers?
My only personal opinion is the way you wrote the 7, it almost looks like it's part of the subscript, so I'd make sure to write it like out here. That might be a board
It's
alignment
just,
thing.
yeah, you're bored.
Alright, so this is Mr. Doc here going to teach you number 6. So first find your A1, which is 19. And then divide, well, not just divide, but just, this one is obviously subtracting by a constant, which is 6. So then we go A of n equals A n minus 6. That's it. Any questions, class, for viewers?
This is Spencer. I'm going to be doing number 8. First off, you're going to start with 108. Ooh, I touched the board. That's a mistake. Start with 108. Divided by 324, you get 1/3. It's decreasing. So that would be your R. R equals 1/3. And your A1 equals 3/24. So the equation would be AN equals AN minus 1.
Times 1/3.
Times 1/3.
Mr. Spencer did great, but just to let you guys at home know, he needs to include A1 and the formula. So like these two things together have to be his final answer, okay? And it just came to my attention that we did have a girl come up and teach a class, and I never explained what she did, over here number 7. She told us the first term was 11, and then every term from there you add 11. So there we go.
Any questions?
Any questions, class? Alright, so let's move on to the last concept of the day, iterations. A cookie. Okay. Hey everyone, I lied. We're not doing iterations yet. We're going to do 2 of these more difficult ones together as a class. So that basically sit at the top. For some sequences, it's difficult to write an explicit formula. Anything that's arithmetic or geometric, explicit formulas are easy to come by. But in these 2 cases, they kind of, you can't come up with an explicit because of what's going on. In this particular one, they're not adding a constant amount each time. They're not multiplying a constant amount each time. There's really no squaring going on. They're using previous terms to get where they're going. Does anybody see the pattern? They're adding the 2 previous. So we kind of saw this yesterday. If you have to use the 2 previous, you have to initialize the sequence by giving the first 2 terms. So term 1 is 1, term 2 is 1. And then to go from there, you add the 2 previous. So you're going to say, I take the previous, which is A1 minus 1, and add it to the previous, which is A1 minus 2. Does that make sense? I believe we saw the exact same pattern yesterday with different numbers. Yep. Maybe. Alright, let's try this one. This one's even a little harder to come by. It does not deal with previous, but it deals with the concept of n. Do you remember that from yesterday? What's the concept of n? Whatever term you're on. So we're going to go ahead and initialize the sequence by saying A0 is 1. And then here is how they get the next term. They look back at the previous term, and I believe they multiply by n. There would not be one this round. So this is super difficult to come by. So like to get, this is term 0. A0, label it. But to get term 1, they took the previous term, which was 1, and they multiplied by n, which since we're on the first term is 1. Does that make sense? Let's try to explain how they got A2. To get A2, they looked at the previous term, which is 1, and they multiplied by the number of terms that they're on. Okay, that's going to happen. And term 3, they would take the previous term of 2 and multiply by 3. So that's a hard one to come up with just out of your own mind. Alright, now we're going to go to our last concept of iterations. An iteration involves the repeated composition of a function within itself. I would just write down the first sentence, that's all I would write down. So I'll pause the video and allow you time to write down that first sentence. Hello people in the video, here's our first example of an iteration. We're going to find the first 3 iterates, x1, x2, and x3. Now they're going to always start you off by providing x0, that's going to be like your starting amount. To find the next iterate, you basically take the value of the previous and you put that in for x. So you have a function in function notation versus having like a recursive equation. So to find x1, iterate 1, I'll take a 2 and put it in for x, because 2 is the previous iterate. So that's going to be -5. Do you agree? To find the next iterate, iterate 2, you take the previous solution, -5, and put it in for x. So do you agree that's 16? And then to find iterate 3, you take -3 times the previous term and add 1 and get -47, I think. Okay, so you guys ready for graduation problem? Hello, yes?
So say that you.
This is our graduation problem, so I'm going to hit pause and all the students are going to give this one a try, okay?
Hey,
Alrighty Alrighty, raise your hand if you got 5, 17, and 65 as your first 3 iterates. Yay! Congratulations. You graduate.
Yep.
Alright, the homework then is right here, 4 to 36 even. We got the whole lesson in 10-minute video. That's awesome. So hopefully you had fun at home watching, and we missed you if you were absent today. Have a happy Thursday, and I'll see everybody Monday.